Welcome, everyone. I'm Anders Stoll. I'm a solutions architect at Amazon Web Services, where I specialize in helping fintech organizations, such as Crealogix, which we'll learn about later on, to accelerate their cloud adoption journey. Now, in order to accelerate cloud adoption, we can leverage abstractions. Now, let's use an analogy to explain this. On the left side, we have the individual components that make up an engine representing cloud infrastructure and its primitives. On the right side, we have the abstraction of these parts into a complete engine powering the car. This represents the composition of cloud primitives into a platform that allows you to run your application. Now, of course, there are a number of people in the world who are capable of assembling the individual parts into a complete engine and installing it in the car. But this is labor-intensive, it's complex, it takes time. Thus, there's a much larger number of people in the world who just want the engine already installed in the car in order for them to drive that car. Now, in the cloud engineering context, there are also a number of people who can take primitives and build entire solutions out of them. But there's a bigger portion of engineers who don't necessarily want to, nor should they need to worry about composing infrastructure into platforms that are needed to run the applications in the cloud. They just want to build the applications and focus on their end customers. So this is what platform engineering is about. It's about building abstractions that meet your internal customers where they are and allowing them to offload infrastructure management responsibilities by providing an internal platform and allowing them to focus on their end customers. So in this session, you will learn how you can build and use internal platforms for yourself. More specifically, we will talk about why you would need a platform and what it's actually about. We will talk about the key characteristics and elements. And then you will also see that internal platforms can be quite different when you compare them to each other. So we're going to have a closer look at how Crealogix has specifically implemented their platform. And then we also finished the session with a few best practices. All right, so why would you want to have a developer platform? Now, let's assume that you're leading the cloud adoption at your organization. So you're responsible to enable different teams to run the applications in the cloud. That could include migrating, modernizing, or even building net new applications. So you see, you have a wide range of internal customers, which are your software development teams. Now, these teams will likely be building or maintaining applications with different requirements, and those workloads will need to run on a varying set of cloud infrastructure services. Now, these services could entail compute services like EKS or EC2, storage services, database services, networking, and even monitoring services. So already a lot of services that need to be correctly configured. Now, even the configuration for the same service might be very different as the workloads have different requirements. For example, some might require more compute than others, some might require more memory, some might require even GPUs. But regardless of that, all of these applications will need to run in the cloud, and you as the platform or cloud adoption leader are responsible for figuring out how to achieve this. And this brings us to the age-old question of who is going to be responsible for managing the infrastructure that is going to run your applications. Now, the option for this can be thought of as a spectrum. On the one end of the spectrum, you can choose to decentralize infrastructure management responsibilities, where the application teams that build the solutions are also responsible for deploying and maintaining the infrastructure that is needed to run these workloads. The implication here is, of course, that each individual team will be responsible for deploying and maintaining, but perhaps most importantly, for troubleshooting production-grade infrastructure in the cloud. On the other end of the spectrum, you could choose to centralize infrastructure management, and in this model, there are central teams that compose infrastructure services into platform abstractions. These abstractions are then offered as a service to the application teams, allowing them to offload the so-called heavy lifting of infrastructure management. Platform engineering, of course, conceptually skews towards the right side of this spectrum. It's all about building abstractions that allow your application teams to offload the infrastructure management so that they can focus on building products and features for their end customers. However, the abstractions and also the level of abstractions that we see customers building actually differ quite significantly, as different organizations have different requirements. For example, more regulated customers might have a more centralized platform with a higher level of abstraction, as they need much more control than other customers. Now, ultimately, it boils down to the demands of your organization and your internal customers. But all of these platforms aim for the same benefits. Now, first and foremost, it's about increasing the velocity. Customers who have successfully built an internal platform are able to significantly reduce the time it takes them to get innovative, new ideas out into production and in front of customers. By removing the need for each individual team to provision their own infrastructure and providing self-service deployment capabilities, companies can accelerate the time to market for new products and features. Secondly, governance. And in this context, governance is a sort of catch-all for all things such as security, compliance, resiliency, and so on. By building platforms, companies are able to enforce the requirements for these types of concerns in an automated way for all the applications that run on the platform. So every workload benefits from the same sensible defaults built into the platform, and application teams don't have to figure out how to configure these on their own. But that doesn't mean that the application teams are completely relieved of these sensitive tasks, but only that they're given a solid baseline to begin with. And lastly, it's about increasing your efficiency. And this really comes down to cost savings. There are a number of ways how platforms can save costs for customers. So for example, you're able to apply cost optimization best practices through the platform across all the applications, and allowing you to cross-pollinate learnings and findings to each other. Additionally, you will also save on engineering costs by having one central team manage the infrastructure. Now, this team will also be responsible to make sure that the resources are allocated correctly and utilized in a proper way. And these resources can sometimes even be shared across applications. Now, these benefits have led to the widespread adoption of platform engineering and internal development platforms. But I guess many of you have heard of platform engineering, but not everybody knows what an internal development platform is. So let's quickly define this. And here we're going to use the definition that the platform engineering has come up with, which states that an internal developer platform is built by a platform team to build golden paths and enable developer self-service. Now, the golden paths here are the paved roads which developers can take to develop and deploy the applications in the cloud. The golden paths have the right guardrails in place, which allow you to move with speed while still confining to your company's security and compliance requirements. Secondly, an internal developer platform consists of many different techs and tools glued together in a way that lowers the cognitive load on developers without abstracting away context and the underlying technologies. So now if we go back to the car analogy, the internal developer platform is the engine that powers the car, or in this context, your applications. And if you open up the hood of a car, you will still see all the individual components, but already correctly assembled so you can drive that car as you get in. And that's the same case with the platform, right? You can deploy applications to the platform and it works right away. And the last piece of the puzzle, and a very important one at that, is that following best practices, platform teams treat their platform as a product and build it based on user research, maintaining and continuously improving it. Now, this definition still leaves a lot of room for different styles of implementation, but ideally, an internal developer platform covers a core set of components. The platform should allow for application configuration management that enables you to versioning, sequence management, and so on as code, so it's in a standardized, dynamic, and scalable way. The platform also allows you to orchestrate all your techs and tools glued together to build the so-called golden paths, so essentially integrating all existing tools as part of a proper CI/CD process. Developers should also be able to self-serve, fully provisioned environments on demand, and which removes a lot of bottlenecks, especially on the platform team, and enables thus faster delivery. And this brings us to the next point, where the IDP implements a pipeline for continuous delivery, or even continuous deployment, and allows you to have a record of each deployment, making it easier for audits in the end. And lastly, the platform should allow for fine-grained access management depending on the type of role, the type of application, and the environment. Now, if you want to build a platform in AWS, there are certain building blocks that you can use. at the core, there are services like AWS Control Tower, AWS Organizations, and AWS Service Catalog that allow you to pave these golden paths and set the correct guardrails along them. These services are key elements of your internal developer platform, and almost every platform builds on them. Now, when we have the more proprietary building blocks, we can use infrastructure as code that helps us with your infrastructure and environment management. Here you have different tooling available, ranging from native tooling such as the CDK or CloudFormation, up to source available or open source tooling such as Terraform, OpenTofu, or Pulumi. And lastly, for the self-service part, here you could use open source frameworks such as Backstage, or managed solutions such as Rodi, which essentially is just built on Backstage, or even closed source solutions such as Port.io. Now you see there are numerous options here, and let's shift a gear from concept to implementation and have a look at how Creologics have specifically implemented their platform. And for that, I give the word to Tamer.
Thanks, Andre. Hi, everyone. My name's Tamer Husner. I'm a cloud architect at Creologics and one of the engineers responsible for our internal developer platform at the moment. And I think it makes sense to start where we were before we had a developer platform. So when somebody wanted to request a cloud resource in Creologics, it was a ticket-based system. So they'd open a ticket in our IT service system. And this is not bad per se. The issue here was it was assigned to the operations team, which also handled tickets for our data center. Now, our data center was established, it's mature, we have customer workloads on there in productive environments. So these tickets always took priority over our cloud tickets. This led to developer frustration, long delays, and to make matters worse, we also then had inconsistent deployments. So what worked in one account might not work in the second account because the role was missing a critical infrastructure. What we wanted was these three things. So automation. Why should we wait for a developer or an engineer to come along and actually provision something for us when we know automation can do it for us? The second point was governance. So we work in a regulated industry, and governance is really important for us. We have many audits, we have many security checks. If we automate our setup, we know that this cookie-cutter approach should give out the same security checks in every single account for us. And so we can design security into the solution. Finally, we wanted to have speed. I mentioned earlier there was a lot of developer frustration due to the delays, waiting for someone from operations to come and provision the software for us. Why not just have this automatically be triggered the moment that it's been approved by a manager? So we looked around, what building blocks do we have inside of our software infrastructure that we can use to develop a solution that makes this automated for us? ServiceNow is our IT ticketing system. It's established. The management approval flow is already baked into it. We're going to use it. We're not going to invent something new. Our automation chain is Terraform and GitLab. Terraform is a widely known, widely supported automation IAC tool. We have experience in the company. Why try something different? We can use this. GitLab is our SCM tool and the pipeline automation, so we carry on using that. AWS Control Tower gives us multi-account governance. It gives us those security checks that we require. Gives us a landing zone, so it's all of these conveniences that we require. And Service Catalog plays very nicely with Control Tower to provision an account that is governed by Control Tower for us. The final one, Backstage, looked really cool. So that's the reason that I picked this one out to start off with. But we also wanted to have a friendly self-service tool at the front end for our QA testers, for our developers, to be able to go along themselves and then configure what they wanted to have in an environment. That was picking the building blocks. Then we had a lot of experimentation, a lot of whiteboarding sessions, and we came up to two flows that we now have implemented and work quite well for us. The first one is for accounts or organizational units. Now, I'll explain later on how we use OUs and accounts in Creologics, but the flow looks like this. ServiceNow is where the request comes in. This can be an engineer, a QA engineer, a performance engineer. We want management approval for a new account or a new organizational unit. This is because we use OUs and accounts in Creologics for business purposes. It could be a new project, it could be a new product, it could be a new environment for an existing product. So, for example, you want a performance and test environment for only 2 days for an existing product. We go through the management chain for this. As soon as the manager approves this, ServiceNow automatically triggers the GitLab pipeline API. So there's no delay here. We've ticked off that first box, the speed box. And this uses a GitLab runner to execute Terraform code against our AWS setup. So the end result is we get a control tower managed organizational unit or a control tower managed account. So that's now automatically created for us, hands off. And it's already governed because it's part of the automated flow. The flow for infrastructure within an account is slightly different. This is the part which is self-service. We don't want to have management approval for this. I'm not being nasty, but I don't want the manager to approve something technical. Here we have a technical lead, a software architect, someone who knows the infrastructure necessary, and they approve this. And what happens is, Backstage, I mentioned, has a very nice, friendly, self-service front end, which we've built. Engineer X, who wants to configure their environment, knows what they require. If it's a performance engineer, they need a big, beefy environment. If it's someone doing a POC, they can have a very small environment. They configure this through our guided process, and at the end of the process, Backstage creates a merge request in GitLab, which someone senior, here I've got a tech lead, can actually check, is this person provisioning infrastructure that's correct for this kind of use case? And the moment they approve it, again, GitLab is triggered, the pipeline flows, and we use Terraform to apply infrastructure within an account. So, for example, VPCs, Kubernetes clusters, etc. This is a point I wanted to talk about because AWS AFT, which is Account Factory for Terraform, looked perfect for our use case. It looked brilliant. So if I read the blurb for it, AFT is an automation framework to provision AWS accounts using Terraform. It integrates with AWS Control Tower and Git-based workflows to ensure consistent, secure, and auditable account setups. I read that and I thought, brilliant, it does exactly what we need. We experimented and we actually decided to use the CLI directly instead because it's much, much simpler. For our use case, we didn't need the full-blown AFT. We could use the CLI. With the CLI, I have full control. I can configure exactly what I want, and I have full control over what I do when I do it. The setup was really fast. I mean, AFT requires its own account. It requires within their code pipeline, Lambdas. It's a large setup. The CLI, I installed it on the GitLab runner, and it was already there, available for us to use. This was really important for us, the single pipeline. We use GitLab pipelines, and we like to have pipelines that start and finish for the entire process, so we don't have to go looking through different dialogues to see what's happening. If we would use AFT, it's a split pipeline, because AFT uses code pipeline for its work, which means I'd trigger a process, follow it in GitLab, and then jump somewhere else to see what was happening. Not ideal. And immediate feedback. The CLI tells you basically straight away if you've screwed up the command or not. You can see if something's happening. It was a longer process to get to the actual implementation. It didn't happen overnight. We did it in steps, and the steps for both flows are quite similar. We started off with Terraform. The platform engineer could execute our Terraform project just by providing variables, and it would generate for us either the OU or the account as we wanted. It's useless on a platform engineer's machine. We wanted to have this automated, so then we added a GitLab pipeline to surround this so that the automation was in place. And we finalized the process by plugging in the service now request to GitLab, as I mentioned earlier, to trigger the flow. And the important part as well below is tying the two flows together. Backstage has a concept of a catalog, and we use the catalog to build up our, let's say, the organization within AWS as well. And that means we tell Backstage, hey, we've provisioned a new environment. It's called ABC. When someone comes to provision infrastructure, give them ABC in the list that they can configure this to. So let's look at how we did the resource provisioning. Again, started off with Terraform with local setup. We implemented modules for all of the important components. We then wrapped these modules up into an environment project so that we could basically configure an entire environment with a couple of TF-vars files. For those who aren't aware, a TF-vars file is a file where I can specify key value pairs, and Terraform then accepts these, and it does what it's supposed to do. We used it to configure, to turn things on or off. So, for example, an RDS database on or off, the size of my Kubernetes instance, etc. And using the same source, we could configure different environments. So in my example here, Dev1 has a Postgres Aurora database, and Dev2 has a Oracle RDS database, but it's using the same source code to get it done. Again, useless on an engineer's laptop. We added the automation framework around it by providing a GitLab pipeline. Now the commit was a merge request, so we had the 4 eyes concept. And the part that's really cool is we added Backstage for the self-service, so you no longer need to know how this file looks. It was a friendly interface for people to click through and configure what they needed, and then Backstage itself would create the TFVARS file using its scaffold and templating, create a merge request in Backstage, which then a technical lead could check, and then it would trigger off the provisioning for us. Crealogics, we are a company built up of semi-autonomous business units. So each business unit has its own development teams, it has its own products, its own projects, but they share some common resources such as HR and me, for example, the guys who do operations. So the way we built that up in AWS is as follows. We have inside of our root organizational unit the management account. It's a single management account because we are a single company. Control tower is there, organizations is there, identity center is there, and we have a single global networking account because, as I mentioned, it's semi-autonomous. It doesn't make sense for every business unit to have its own networking set up. We share this. We have one global networking which handles all the complicated networking into the data center, the VPN, all the stuff that I don't understand that network engineers do. Each business unit is created automatically using Terraform again. And when we create a business unit, we have a standard pattern for them. They get an OU called deployment. They get an OU called tooling. And then there is a list, 1 to N solution OUs with accounts in them. And that's the part which is self-service. This is what they can trigger themselves from ServiceNow and from Backstage. In tooling, we have an OpenSearch instance and a Grafana instance. And all of their accounts are automatically plugged into here, so they get a single pane of glass observability solution. We've automated this for them as well. It's optional for them. And deployment OU is where we have the deployment user for each business unit. The Terraform states are persisted in here. And the actual magic that allows us to automatically use an account immediately after vending occurs along with that as well. And I'll show you what I mean with that. So this was the trickiest part of the puzzle for me. We vended a new account. We've put it into OU. How do we access this account to automatically provision infrastructure when no one can actually access the account yet? We need a role in there that we can assume. This role also needs to be tied to the business unit because we don't want separate business units to be able to access separate business units' accounts. And we solve that with this setup here. So on the left, the management account. On the right, an OU called, business unit, called ABC. As I mentioned, we create a deployment OU for them automatically and an account in there. During provisioning, they get a user called deployment. It's an IAM user. Their keys are persisted in a vault. We can get them out when we do CI/CD operations for them. But this user can't do much. It can do S3 and it can do KMS. It's Terraform. They also get a user policy. And this user policy says, by the way, you can assume the role, CI/CD role, in any account as long as it's within the Crealogics organization. We then create all of this again with Terraform and GitLab during BU creation, a stack set inside of the management account, which says, by the way, your job is to inject the CI/CD role into any account within the organization ABC. So this stack set is sitting there and it's watching, and the moment it detects a new account, there's one new account, it executes. And it injects the CI/CD role into that account. This is the role we assume with Terraform to create infrastructure such as the VPC, the KMS setup, everything else. And that role gets a trust policy attached to it. And this trust policy says the only person who can assume you is the deployment user from this specific account. So that's how we tied that up together. It's locked, yeah? No one can do anything in this account apart from the deployment user, and the deployment user can only assume this role. So that's how we tied the security part together. This is what most of our accounts look like now. This is a standard pattern for architecture inside of Crealogics. We have, when we create a new account, a VPC. And this is automatically tied into our central DNS and transit network via the magic from the network engineers. The EKS cluster can be configured in the front end. The databases can be configured in the front end. And what's nice as well is we push Argo CD onto the EKS cluster once it's been deployed. And then, if the user knows where their application manifests are, they're allowed to put that into Backstage. This means once the application comes, Once the infrastructure is provisioned and Argo CD is running, Argo CD can then actually deploy the application. And I've talked a lot. It'd be cool to actually see it happening as well. So this is ServiceNow in Creologics. This is our service catalog. This is me going along to the platform engineering service catalog section, and you can see here we can create or destroy OUs and accounts. A solution is what we call an OU in our terminology. The contents of these drop-downs, it all comes from Backstage, which is where we build our organization. And usually this step would then be sent to my manager for management approval. For the purposes of the demo, it came to me, so I could approve it myself. There's the little notification. Go along and I approve it because I think it's cool. This person is allowed to have an AWS account. Hesitation. Then I click on it. And we should see that it goes to in progress. And if we jump to GitLab, we might catch the API triggering just in time. So the API has been triggered, and the job has started. Now, that job takes about 7.5 minutes. And this job created the new account for me, and it also put it into Control Tower, and it put it in the right organizational unit at the same time. It's quick. What's interesting in the logs, I used the Service Catalog API via the CLI to trigger a new record of, the text is too small for me here. I provisioned the product of Control Tower account type. I knew that. And we can see that here. The account's been created, but I can't access it yet. Remember, the CI/CD role needs to be injected into the account. We wait for that to be injected by checking the StackSet API, CloudFormation StackSet API. As soon as it's been injected, we know, hey, we can actually access this account now and configure resources in the account. So the next step actually logs into the account, assuming that role, and creates our DNS setup. Finally, I mentioned we need to update the catalog. If I don't update the Backstage catalog, there's no way to actually select this account later on. And that's what happens in this step. So Backstage now knows there's a new account. It's called BBB. Someone can select this for provisioning infrastructure. So it might make sense to have a look at how that's actually happening as well. This is the Backstage setup that we have in Creologics. And these are the templates where people can configure whatever they want to that we've implemented. For me, it's provisioning an AWS environment. And in this drop-down, you'll see the account that we created before, BBB, is there, and I've selected it. Now I can provide manifests for Argo CD. I've prepared this demo. I know where my application is. I'd like to have something deployed at the end of it so we can see something interesting. Thanks to the network setup as well, we have access to the internal Creologics network, so I can use our internal GitLab instances. And you can see here, we can step through the setup, configuring different parts of the infrastructure. With the databases, we did something that I think is cool. We show the developers different size of instances and the cost. We want to make people cost aware. If they choose a Postgres instance, it's not running on RDS, or it's not running on instances, so they get ACU options there. We do the same thing for EKS. Version is supported. People can choose which version they want. They can also choose the worker node type. Again, the size of the worker node type. The size of the environment, in case they're running a performance and load test environment, they want to have something a bit larger. And again, for cost reasons, we can spin the environment down at nighttime. A few more bits and pieces. The observability agents, at the start, I mentioned we have an observability setup. It's optional. Finally, it checks the credentials of who is actually opening this merge request, and then it will open a GitLab merge request. I forgot. First, it gives you a review, so you can check what you've done, that you haven't made any mistakes. Which I seem to have checked quite thoroughly. OK, and here's the Backstage scaffolder running. It's done the actual templating, and it creates a merge request in GitLab. Now, this would be assigned to the code owners, people that you've decided are responsible for this repo at the moment. For the demo, I assigned it just simply to myself. I was able to merge this. And you can see, once I make the screen bigger, I mentioned at the start we have this TF-vars file. This is the TF-vars file. And what I chose in Backstage for the environment is what's been populated inside of this TF-vars file. This is the part that helps non-technical people configure and yet still deploy what they want to have. Because I could create a TF-vars file, but not everyone is a platform engineer. Once the merge request happens, the process gets triggered. Here is the end of our provisioning for an entire environment. It takes less than 20 minutes, but I didn't provision a database. With a database, it takes about 25. I still think that's very cool. And interesting in the logs at the very end here is, once EKS has been provisioned, we use Helm to deploy Argo CD, and then we deploy applications as well. And if you remember at the start, I gave manifests for an application called BBB. We can look at it. So what's really cool, when we deploy Argo CD, we use the EKS add-ons for load balancer controller and external DNS, which means after about 5 minutes, we can actually access Argo CD. It's running, it's in our environment. The credentials I can extract out of the secrets manager. And if I log in, I actually will see my application is there. It's up and running, BBB. Wonderful naming by me, by the way. So here it is. It ran. It executed. We can check that there's no issues. There's no errors in the logs. Yep, all green. Logs look good. It's actually coming from our Artifactory inside of CreaLogix. Again, the networking is working. All of our setup is correct. The manifests are coming from the GitLab repo I configured at the start. And if we check the application, it's really there. It got deployed automatically, hands off, everything from infrastructure to the application, all within about 25 minutes. I'm not a front-end developer, which is why my colors are horrible. I won't win any UX awards. But I hope the rest of the stuff was interesting for you. Thanks a lot. And I'll hand over to Andre.
Thank you. Thanks, Thomas. I think this was really interesting and gave us all a really good look into how one could implement a developer platform. Now, as I already promised, I think we're going to finish the presentation with a few best practices that you could use to implement a developer platform yourself. And first and foremost, one of the biggest mistakes that we see with customers building platforms is that they build something without any sponsors or workloads in mind. Now, the most successful platform teams have sponsored projects or workloads, and it's important for them to make the developers and the engineers, so your internal customers, part of that journey and build together with them. This allows you to incorporate the feedback early on and build something that will be actually used in the end. So that's probably the #1 success factor. Secondly, don't try to boil the ocean, but start with a few use cases and expand the platform from there. Pick compelling use cases in the beginning and work with developers to continuously enhance the platform rather than rolling out with a big bang. And of course, there won't be one-size-fits-all platform. Right? Platforms across different organizations look very differently as they have different requirements. Right? Different level of abstraction, different patterns that they need to provide. They're going to use different technologies, different building blocks, and so on. And also your internal customer base will have different demands. Some might need more autonomy, some want less autonomy, some want this, some want that. So you see, you won't be able to satisfy every single little request that is coming from internal customers, but the platform should strive to provide the largest common factor. And lastly, self-service tools are great, but they only work if developers know how to use them. So that's why investing in things like tutorials, office hours, and clear documentation is very important. These resources make it easier for developers to get started and solve problems on their own. And this allows them to walk also this golden path, as we mentioned them before, by themselves, which also then frees up the platform team, also people like Thomas, to continuously improve the platform and instead of answering the same questions over and over again. All right, so let's get a few takeaways for this presentation. First, Platforms provide you with abstractions that allow for easy adoption of cloud services in the cloud. They also give you economies of scale, resulting in increased velocity, cost savings, efficiency gains, and also enhanced security posture. But it's important that you treat your platform as a product and continuously improve it. So you need to incorporate the feedback from your internal customers, so the developers and the engineers in your organization, in order to improve and enhance the product and build new features into it. Now, I hope this talk gave you a good idea what internal developer platforms are about and how you could potentially use one yourself at your organization. You also saw how Crealogics have implemented one specifically, and hopefully that will get you to do the same thing and motivate you as well. Now with that, I would also like to thank you for your attendance and your attention, and also a very big shout out and thank you to Tama for being my co-speaker here today. And if you have more questions, we will be around for the next couple of minutes, but you can also reach out to us using LinkedIn or whatever other platform that you use. And maybe you also already have an account team or an account asset that you can talk about this and hopefully get you started as soon as possible. One last thing, we would greatly appreciate if you could fill out the session survey. This helps us quite a bit. And with that, thank you again and see you around at the reception. Thank you.
It's cool, man.